This is 6-65, and it says rewrite each expression. In parts A and B, write your answers without negative exponents. In C and D, write your answer in scientific notation. Okay, so the ones that look like scientific notation, we're going to write it in scientific notation. I'm very glad that you asked this because this has been an ongoing struggle with the class, the negative exponents, and it's not just particular to this class. It's just kind of a hard concept to understand. So does anybody have any ideas how to write that with no negative exponents? Sandy does. What do we do first?
Well, like 5 to the 0th power is like basically 1.
Uh-huh.
So you write that as 1. And then for 2 to the negative third, you like do that downstairs thing. So it's like 1 over 2 to the 3rd power, which would be like 1 to the 8, 1 over 8. So it's 1 times 1 over 8.
I don't need to keep writing 1 times something, right? Because, I mean, it's just 1/8, yeah. No, I was writing it just to show that what happened to my 5 to the 0. So we're supposed to memorize, and we're supposed to just kind of have an understanding that anything raised to the 0 power is 1.
So A is pretty much just 1/8?
Yes.
Where did you get the 8 from?
Where did we get the 8? Go ahead, Sandy.
Because like 2 to the 3rd power is 8. And
Yeah, because 2 times 2 times 2, right?
Oh,
Oh, yeah, see? Yeah, that's the exponent thing for you. Okay, so that's A. Let's do all of them, though, because these are good ones. Here's letter B. So we got, so Sandy, you got a handle on these things, I guess.
Sort of.
And then we got A, B squared, and A to the 4th.
Oh my gosh. These ones is crazy. This is going to explode, everybody.
What, does anybody want to get rid of these A's right here?
Kenny?
Isn't it a giant 1 right here?
Yes. Yeah, so now I guess it's just...
A over A is 1, so they can kind of just bloop, bloop, they disappeared, okay?
So now it's just A, so A, 3B. Wait, where'd the B come from? B is already there.
It was already there.
Oh, wait, but where's the 4?
Oh, wait, was it A to the 4th? Oh, okay. Sorry. Okay, so this is now A to the 3rd, right? Because I took one of the A's and canceled it up there. Is that all right? Hey, look at these. A to the 3rd and A to the 3rd, they're the same exact thing.
So now you have B over B to the negative 2nd.
Yeah.
Well, what happened to the B, 3rd? B
I don't...
squared. So so now it's B.
No, I just left it off. Thank you, Sandy.
This is a little easier, I guess.
Now what?
You can't really cancel out. It's just B, because when it's like that, you can subtract it, so it's just B.
Well, kind of. You can subtract it, so you're going to go
Exponent.
2 minus negative 2. So is 2 minus negative 2 nothing, or what is 2 minus?
4, so it's B4.
Yes. So Sandy remembered our rules. So if you guys want, and I will show you the rules, if I have like A squared times A to the 3rd, that's going to be A not 6, 5. You know what I mean? Because you add the exponent.
You add, not subtract.
If I have A cubed minus, or over A squared, that's A to the 3 minus 2, that's A to the 1, which is A.
Okay, but wouldn't that work with that one too then? Like 2 and then the negative 2 of the exponents, wouldn't that like subtract it? Or
Yeah, but, well, when you subtract a negative, you get a positive though, like...
Is it like the thing where you like switch it and it becomes like positive and negative?
Yeah, it's kind of like that too. So this...
I thought the negative token could hold a positive token. Okay, all equals 0. Now take away what you need.
So if you want to think of it as, remember we told the story about he's unhappy with his downstairs apartment because he's got a negative attitude. So then when he moves upstairs, he has a positive attitude, and then you can just add those two and you get to 4. If that makes better sense to you than going 2 minus negative 2. So there's so many different ways to do it. That's, I think, why it gets so confusing. But basically, if you have two things multiplying together, you add the exponents, and if you have two of the same base,
You like divide or subtract?
yeah, dividing gives you a subtraction.
You add or subtract.
Yeah, you either, when you're multiplying, you add, and when you're dividing, you subtract. So that's pretty much it, huh? That's pretty simple. When you're multiplying, you add. When you're dividing, you subtract. And that's actually true for logarithms too, like in my pre-calc class. Okay, let's go on to the next one. What's the next one? Letter C.
Yeah, except now we have to write C and D in scientific notation.
Oh no.
I hate scientific notation. Just kill me now.
So, is there any little trick rules that are that'll make it easier for us to do this, or do we have to do it out the long way?
I think we might have to do it out the long way.
I think Emma has an idea. Do you have an idea, Emma?
Yeah, but on negative you just go like, you kind of just like, since it's times 10, you just add zeros to it. Like if it's a negative, you just put like 3 zeros.
Oh, okay. So that is the long way. So most of you seem like you want to do it the long way. What do you want to do, Sandy?
Or if you could just like completely forget the tens and then just like multiply 2.3.
Yes, that's the short way.
Wait, hold on. And
I don't
then
have an,
so that's like 9.66, and then 10 and negative 3, and then 10, where it's like 10, right? That's 10 because it's 10 to the 1 power. So it'd just be 9.66 times 10 to the 1 power.
These two, you are doing great. Yes, you can take the number part and just put it in your calculator, or she probably did it on paper, or I don't know how you did that. Calculator. Put it in your calculator and you get 9.66. And watch this. This is the short way. Now I can multiply these two together, because it doesn't matter what order I multiply stuff in.
Yeah.
So now I have -3 plus 2.
1. It's times 1. 10 to the 1.
-1.
10 to the negative 1, that's 1. Oh yeah, negative 1. Okay. Because negative 1 is kind of equals 0.1. It'd be...
Yeah, it's 0.1. You're right, it's 0.1. But we have to have scientific notation, so now we just write it like this. 9.66 times 10 to the -1, because that's actually scientific notation right there. We use X's for times when we're doing our scientific notation. So that was the shortcut way. We could have done it like how you and Emma were wanting to do it. You could you can move this 3 places to the left, and then you can multiply this go 2 places to the right. But then you end up having to change it all back because they require us to write it in scientific notation. So then you would have had to go back and change it back into this anyway. So this is the shortcut. Here's letter C, or no, letter D.
Oh, letter D looks slightly less complicated, but that's only because there's less numbers, not decimals.
Sandy, what idea do you have?
Wait, look, okay. It's 3, you could do 3.5 times 10 to the third times 3.5 times 10 to the third.
You could, or Sandy?
Well, since it's like squared, it's basically the same thing twice, so 3, that's exactly what I just said.
Okay.
3.5 times 3.5, right? So that's going to be like 3.5 squared, but also like 10 thirds plus times 10 thirds, that'd be like 10 sixths.
Yes.
That middle one is not X, that middle one is the...
It's timesing. Yeah, I wrote it with a timesing. That's not an X, you're right. So 3.5 times 3.5, I'm just going to ask my calculator, what is that? 3.5 times 3.5. Well, that looks like that's 12.25, so that's not too bad.
So the answer is just 12.25 times...
Hang on. Is that in scientific notation right there?
No, it'd be 1.225 times 10 to the 7th.
Yeah, wait,
Oh.
25 times 10, let's see, when I did, yes, times 10 to the 7th. How'd you do that so fast, Sandy?
Because you like go to the left and then you add 1 to the 10. Because you take away a base thingy, like tenths, and then have 10,000.
Yeah, so I kind of think of it like, if I moved this left, I kind of made this number smaller, so I have to compensate for making that number smaller by making this one bigger, you know what I mean, so that I haven't upset the balance of the universe. Rocco?
Wait, are we done with this?
Yeah, I'm gonna turn it off here. Let's turn it off.